mainly about IP addresses. And we learn about a MAC address also. So I will tell first about a IP address, and then I will add few information again about a MAC address, because what is the difference between IP address and MAC address is there. Plus how to check IP address, and already you know how to check MAC address. So anyway, so in both the ways we can see both the things. Okay, we'll see what is the IP address first. IP address is a logical address. IP address is a logical address. Okay. Unique. It's not a unique IP address, guys. IP address is a not unique IP address. It is a uniquely identified a device in network. So to identify a device in the network, okay, we need an IP address. Two important points are to put it here. First one is all communications means in network by IP address only. Okay, not with the MAC address, not with the name. So mainly we need an IP address. Devices in network devices to communicate in network, we need an IP address. Without IP address, we can't communicate. So these are the main two important points. Okay, so it's a logical address, uniquely identify a device in the network. Okay, so devices to communicate in the network, we need an IP address. All communications by IP address. Address assigned or configured. Those are word also assigned or configured by manually, means a person can able to assign an IP address, or automatically also get assigned by DHCP server. So DHCP server assign an IP address to the devices automatically. Okay. So I was required to draw something. I will try drawing. I have a device and I have a devices. So it's symbolically saying the devices are in network. Maybe they are connected to switch or not. So otherwise we'll remove this one. We'll use some switch or a route or a hub. Okay, just because it's new to you. So I'm connecting devices in network. So that is, I connected devices in physical. To connect it, so what is it is required? We need a NIC. We need a NIC. We are connecting to NIC only, right? NIC of a device. Whether it is wired or wireless, just for understanding, I am giving this wired connectivity. Wireless or wired connectivity, we need a NIC. Every NIC has a MAC address. Every NIC has the MAC address. Every NIC has a MAC address. So we'll write, for example, this is APC. Okay, so I put APC-A, PCB, and PCC. Actually, I put a 5 systems like that, but I given only this. Okay. APC has an IP address. For example, this is some IP address I given.
So is there any particular format to write an IP address or what?
Yes, we have a format to write an IP address. And in IP address, we have a 2 versions, IPv4 and IPv6. Okay. So PCA also means the NIC, the NIC, which is having a MAC address. Yes, MAC address, non-NIC is MAC address. We can write. There is some example MAC address also. Okay. On NIC MAC address. The MAC address cannot be changeable. MAC address cannot be changeable. Next, one text I will add from A. So I am at A, I want to communicate it to B. Okay, from PCA to PCB, I want to do ping test. Ping is a test command, right? So at PCA, so what I'm doing is I put a command called ping and PCB IP address. So I'm communicating with a IP address only, not with a MAC address. You cannot use ping B's MAC address. Okay, so that is the identification. Identify a device in the network. So without IP address, we cannot communicate. Either it is we required IPv4 address or maybe an IPv6 address. But compulsory an IP address is required. Okay, and every NIC has to connect. That is already I told part. Okay, so once again guys, what is an IP address? It is a logical address. First thing is logical address. uniquely identify a device in the network. It is a IP addresses logical network. Based on IP address, we divide a network into logical network. Okay, so IP address defines a logical address. Logical network. It does not mean MAC address define a physical network. No, it's not like that. Okay, so we have discussed two things. One is physical topologies, logical topologies. Logical topology means logical network which is by IP address only. So this is a 1 or 2 points, guys, but again, so we need a difference of MAC address kind of stuff, right? So I'm going to MAC address, then I will add few things to IP address if possible. IP address can changeable. We can change IP address, of course, by manually or automatically. Manually can change it. It can be changed automatically by DHCP server. What is the MAC address? Every device any device wants to connect in network, it need NIC, network interface card, whether it is wide type connectivity or wireless type of connectivity it is. Okay, every NIC has MAC address. Every NIC has a MAC address. This MAC address also called as physical address. So if you see somewhere like a physical address is, it means it is a MAC address. Okay, it's also called as physical address or a hardware address. Okay, so MAC address why it is only one version. It is a 48-bit in size. Okay, and in hexadecimal number. How many hexadecimal numbers are there? 12 hexa numbers are there. Hexadecimal numbers are there. Represented in 12 hexa numbers. 48 in binary. Actually, we write in a 12 hexa number. So present in 12 hexadecimal number. Okay. So what are we missing? Yeah, example and how the MAC addresses look like. So we'll see. So 00, 0C, D3, F4, okay, 8, 1, 7. Okay, something. So it's a 12 hexa numbers are there. Even 000 also one hexa number. So this is how we stay. And we cannot MAC addresses not changeable. As assigned by manufacturer of NIC. MAC address is assigned by manufacturer of NIC. It's a manufacturer of NIC. MAC addresses cannot be changeable. I will give one point, guys, that is MAC spoofing is possible. Okay. And MAC binding in Wi-Fi networks possible. What is MAC spoofing and MAC binding? So in a network,
hiding the MAC address and all.
very good. Hiding original MAC address. Okay. So that is used for both protection and as well as a attack purpose. So when I'm trying to send a packet, the packet will send your source MAC address and source IP address, destination MAC address and destination IP address. So what I will do, using certain softwares, I'm not changing my original MAC address. I send with another MAC address. Another MAC address. So I want to hide my MAC address. I want to use different MAC address than normal MAC address. Okay, so that is MAC spoof. Another one is there for attacking, means in my NIC, so whenever I received any packet, first it will check at a data link layer MAC address. Then if MAC address confirm, then it is go for a checking of IP address. IP confirms, then other layers, right? OSI layer, other layers will do it. So what people will do, they will mimic this MAC address. They will put a list of MAC addresses. When they receive any packet, they said it's mine only. Okay. So so for a security, you use different MAC address while you are sending. Guys, MAC addresses valid in LAN communication. Won't work in your laptop MAC address or desktop MAC address. No one knows. After once you cross your LAN, once you go to the WAN or internet, your MAC address is no one knows. Okay, no one knows. It's once you cross your router, so your MAC address is okay. So MAC addresses valid only in a LAN network. That is, I am putting in different wise. Why? Because it's not a very important point. Okay, it's not at all point. It is just for our understanding only. I'm giving that one. So you don't mix up with others and don't confuse. Again, every device to connect in the network need an NIC. It's wired or wireless. It can be a laptop wireless or your mobile phone or maybe your desktop. So you need a NIC to connect to the network. Every NIC has a MAC address. This MAC address is assigned by manufacturer of that NIC. Okay, a D-Link, Qualcomm, TP-Link, Intel, Realtek, These are the different manufacturers of NICs. For their NICs, they will assign this one. Okay, it is a physical address. It is also called as physical address. In binary, it is 48-bit, but actually we written in a hexadecimal format. 12 hexa numbers are there. Okay, we cannot change the MAC address. We'll go to the IP address, guys. In IP addresses, we have two versions. One is IPv4 version, another one is IPv6 version. Two versions. IPv4 version is 32-bit, okay, and IPv6 version is 128-bit. Okay. Next, IPv4 represents in a decimal format. And how it is look like this. Anything, no problem. IPv6 represented in hexadecimal format. Okay. It just look like this. Different ways it is, we can say. Totally 8 blocks are there. Each block contains 4 hexadecimal numbers. Okay, so we have to keep it that mind while you are typing A, B, C, D, E, F. Up to that one we can use it.
Up to E only, no, sir?
Up to E. If you are new to this I will tell, guys. In our decimal, we are all using decimal numbers, right? So decimal numbers start with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. After 9, there is no number. 9 is the last one in a single digit form. So next one you want to create 1, 0. Again 0 repeats. 9 becomes 0. 1 will be added to here. And 1, 1, 1, 2, 1, 3, 1, 4. Like that it will go up to 1, 9. Again it becomes 2, 0. Okay, so like that is our decimal form. You take in a binary. Binary is base 2, only 2 forms. Binary 0 is 0, 1 is 1. That's it. No other single digits. It become 1, 0. It is
1,
again
0.
same pattern. It will
1,
be
1.
repeated. 1, 0, 1, 1. Very good. 1, 1, 1 completed. The next one become 1, 3 zeros. Okay. So 1, 0, 0.
1, 0, 0, 1.
1, 0, 1, 0. Very good. 1, 0, 1, 1. 1, 1, 0, 0. 1, 1, 0, 1. 1, 1, 1, 0. 15 means all are ones. Again 16. 1, 4 zeros. Difficult. You can try if you understand. Just it is numbering, guys. It's nothing more. Because it's only 2 digits. Next one again upgrade means 0, 1, again 0, 1, again 0, 1. This next part will be changes. Another system is there that is called an octal system. So most of you people know it, but just because of some people are forget this system. That's the only thing is that it does not mean they don't know. They know it, but almost we ignored it. We are not belongs to that one. Okay, that is some other science it is. And system is also belongs to Indian one only. See, it is octal system, guys. 0 to 7, 8 numbers, 0 to 7. After 7, again, no other digits in a octal system. Okay, so here it is. It become 1 0, 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 1 7. So completed. It become 2 0 now. 1. So how much difference is there? 2 1, 2 2, 2 3. You know, in a decimal format, you say 18, 19, 20. But here you should not say like that. You should say separate digit number. Hexadecimal number. Hexadecimal number is 16. 16 single digits are there. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So same up to 9, same as a decimal number. But 10 is with changes. 10 become A, 11 become B. See, very good. Keep telling. E and F. So it is. What is the F represent? 15 here. 4 ones. This is the highest single digit in the hexadecimal format. Highest single digit. What is a single digit represent in a binary format? 4 ones. It is 4 ones means 4 binary bits. Means one hexadecimal number that represent in a 4 binary bits. Okay. So maximum 4 binary bits. Octal 7 is the last one. If you see 3 digits, 3 binary bits. Okay, if you want to represent octal in binary, so 3 binary bits. Okay, what about this? So we cannot represent. There is no final equivalent value is not there. Of course, this is a BCD. So binary to decimal, decimal to binary. So that is, of course, we can represent like this with the calculation. No direct conversion. You have to do some mathematical calculations. Okay. So it is not all ones. It is 1001. It's not final one. Of last one. Not it is not last one in the binary. Okay. That's the problem. After F, F is a single digit. Now these single digits are completed. Now it is 1 0, 1 1, 1 2, 1 3, 1 4. Okay. So once you reach 1 F, then it is become 2 0. Then it's become 2 0. So this is our binary kind of stuff. Okay. So when you are writing hexadecimal number, so there can be 0 to 9 and as well as A, B, C, D, E, F also there. Okay. So that's why if you see this is, it is also contains numbers and also A, B, C, D, E, F. It's not alphanumeric number, guys. It is hexadecimal number. This is also one kind of decimal system, numbering system. Okay, totally 4 completed, and this is the 5th one. So anything you can write now. So it is a how this IPv6 represented in this hexadecimal form. See, that's the difference between IPv4 and IP addresses and MAC addresses. MAC IP address is a logical address, whereas a MAC address is physical address. IP address is a uniquely identified device in the network, but it is MAC address is every device has every NIC has their own MAC address, which we cannot able to change, and it is assigned by manufacturer of NIC. In IP addresses, every device to communicate in the network need an IP address. Now, device, I didn't say NIC here, device means system has an IP address, not NIC. Okay, so don't confuse there. So it's normal. These IP addresses, either manually you can assign an IP address or automatically will get an IP address from DHCP server. We can change an IP address. Either manually we can change an IP address or it can automatically change it by DHCP server. Okay. IP addresses cannot be changeable, and IP addresses are MAC addresses cannot be changeable. Okay. MAC address is a only one version type of it is 48-bit represented in 12 hexadecimal number. But IP addresses are two versions are there: IPv4 version, IPv6 version, version 4, version 6. So this is 32-bit and IPv6 is 128-bit. So IPv4 actually written in decimal numbers. Okay, it's not exactly a decimal digits. It's a decimal numbers only we are writing, not the digits now. It's hexadecimal numbers or hexadecimal digits we are using to IPv6. This is how it is look like. Okay. This is just for understanding I have given. Okay. Guys, understand IP address and MAC address
Yes, sir.
difference.
Yes, sir.
The next one is small information that is about your IPv4 and IPv6, and then I will tell about IPv4 only. Okay. Just relax a minute. Okay. Meanwhile, I will try to open this one. Magneto.
Thank you, sir.
Sir, you are muted. Sir, your voice is not audible, sir.
1 second, guys. Just 1 second. I'm talking to sir. Okay. Okay. Can you able to hear?
Yes, sir.
Yes, sir.
Yes, sir.
So just a small pause break only. So once I told some story, then I will give you another break. Okay. What is the another story is IPv4 and IPv6 story. Okay. So IP address having a two versions, IPv4 version, IPv6 version. Okay. IPv4 is 32-bit, whereas IPv6 is 128-bit. Okay. So you take 2 to the power of 32. Okay. So it is around 4.3 billion IP addresses. If you are means from IPv4 starting IP address to last IP address, you write in a paper and count, it is around 4.3 billion IP addresses. And you take IPv6 addresses, number of IPv6 addresses, we are getting 3.4 billion billions of IP addresses. It's not a trillion, guys. It is a decillion. The word for this much range is 3.4 decillion IP addresses. We are getting. You know the value. We can calculate the value by to calculator also. So 2 to the power of 32. So this is the exact number, almost 4.294 like this. So there are combined these things. So this is the exact number of IPv4 addresses. Okay, and 2 to the power of 128. So this is 3.4 into 10 to the power of 38. It means 3.4 into 10 to the power of 38. It means take 34 and put a 37 zeros. Okay, take 34 number and after 34 put a 37 numbers, 37 zeros, sorry. And then you can calculate how many crores of IP addresses you are getting. 1 billion means how many crores? 1 billion. How many crores? 1
10
million.
crore.
Very good. 1 million means 10 lakhs. 1 million is 100 crores. Okay. You know, even it is a silly question, but sometimes, you know, some people wantedly ask in interview, do you know what is the, it is 1 billion is equal to how many crores? Or 1 million is equal to how many things? It's just a number system. Okay. So guys, this is IPv4 and IPv6 too. IPv4 represent in a decimal format, whereas IPv6 represents in a hexadecimal format. So we are already seen how hexadecimal digit is there. Okay. Example of IPv4 just before we told. So just some number it is, no problem, anything. But you can see there is a 4 parts are there and separated by a dot. IPv6, we need a more space for that one. Capital small letters, it does not mind about it, guys. Okay. Again, we have to check it. These are the 4 blocks and these are only 2 blocks, means 2 more blocks you have to tell it. Okay, this is an example of hexadecimal number, how it is look like. Again, see 1 2 3 4 and 1 2 3 4, 8 blocks are there. Okay, this is how IPv6 is look like. Okay, next, if you see IPv4 is divided into 4 parts, total 1 number. Okay, so this is one single straight line, so 32 bit. This 32 bit is divided into 4 parts separated by dot. Separated by dot. Separated by dot. Separated by dot. This 128 bit divided. No, it's not divided. That is separately we have to discuss. Otherwise, it's confusion. I'm telling you about few points in IPv4, guys. Again, it's 32 bit now, so totally 32 bit it is. It divided into 4 parts separated by dot. It means 32 by 4, right? 32 by 4. What is each part getting? 8. Means 8 bit. So each part is 32 by 4 means it is 8 bit. 8 bit. Okay. It is called as octet. It's called as octet. So 1 octet means 8 bit. So 2 to the power of 8. 2 to the power of 8 is 256. Okay. 256 means you have to write 0 to 255. Means each octet range is 0 to 255. Each octet is 0 to 255. We have 4 octets because we divide into 4 parts. We have 4 octets. The first octet called as first octet. The second octet called as second octet. Third octet. What is the third octet? Third octet only. The fourth octet called as fourth octet. First octet, second octet, third octet, and fourth octet. Okay. Some people represent these octets in a different manner. Okay. So look like this. This is W, X, Y, Z. Some textbooks, some people having a certain kind of habituation. The first octet represented as a W, second one as a X, third one as a Y, and fourth one is Z. Why? Because of for easy to understanding, easy to calculation purpose. But generally, guys, the first one we call it as first octet, second octet, third octet, fourth octet, like this. You know, each octet size is 0 to 255. Each octet maximum range is 0 to 255 means any octet is you take whether it is first octet or third octet, whatever it is, the number is not more than 255. Okay, the number is not more than 255. Got it? Writing a first IP address 0.0.0. So same thing. This is a start IP address is 0.0.0.0. You know, next IP address is comes like this. Another one is like this. Goes like a numbering system. It goes up to 0.0.254. After 254, it becomes 0.0.255. Okay. I have to write one point. IP address range, exactly say IPv4 address range is 0.0.0.0 to 255.255.255.250. This is the total range of IP addresses. So starting one is 0 and this is, and keep writing, look at that. After this one, it become like this, 0.0.0.1.0. Means 255 completed, it is next number like a 99 completed, 100. Same way, 1 will come here and this become 0. And it continues 0.0.1.1. 0.0.1.2. It will be like that only. 0.0.1.255 reaches. Then what will happen? It become 2.0. Okay. Become 2.0. Again 2.1, 2.2, 2.3. It keep goes and it reaches 0.0. 255.255.
Hello. Hello.
Okay. So okay. So look at here, guys. Understanding?
Yes, sir.
Yes, sir.
Yes, sir.
So this is 0.0.255.255 again 10. It keep goes like this, guys. So nothing is there. So it will keep on going like this and reaches 0.1.255.255 like this. Then it is become 0.2.0.0. Okay. Also keep go to up to and it is become 255.255.255. Once it is reaches, again it is like this. Okay. If you have really patience, then you can try in a different ways. So 1.255.255.255. So what is the next one? So 2.0.0.0. It goes. Finally, we reach 255, 255, 255, 255. This is the complete range. If you keep putting in numbers from this to this, okay, from here you start and start writing one by one, one number, you write and you reach up to here, and this is the last IP address in the IPv4 range. Means the total numbers you count from here to here, the total numbers are 4.3 billion, means you will reach this number. You want to test, take a one paper and start writing and count it. Okay. So that is
With
your
permutations we can count.
You tell me.
With permutations formula we can count, sir.
Permutations. Yeah, we don't go to that. Okay, I didn't remember also. Okay, so this is very simple. So if you are I'm keep writing like this and I reach here to understand this is next one is like this. Okay, it is always like a numbering system, guys. After 99 you will get a 100. See, if you really divide in a 2 digits manner, so you will understand this is 999 becomes 00 and become 1. And it is become 199. And what is the next one? Automatically 200. Okay, you reach 999. What is the next one? So it is become 10,009. Okay, so same way this numbering system is also. This total can say total IPv4 addresses divided into 5 classes. Divided into 5 classes. Okay. Divided into 5 classes. And first octet means the W based on the first octet of IP address, we can recognize which class of the address because of it is divided first octet only, based on first octet only. Not everything it is not taken, only first octet wise only it is divided into classes. Recognize by that one only. Okay. So classes are like this: class A, class B, class C, class D, class C. So we have a binary kind of stuff is there. So first octet, the first number is, what is this first octet part? 0, right? The starting is 0. The last one is first octet. The last IP address, first octet is 255. Okay. And first IP address, the first octet is 0. You write that 0 into the binary. Alright, that zeros into the binary. Now we follow a rule, and if you don't remember this part, guys, it's okay. Only remember mainly ranges are important. Okay. So how they made a ranges? So what are the first bit you are getting in a class A? Class is the first one. What are the first bit it is? It is a 0, binary 0. We'll keep it like that. Remaining become ones. Remaining bits, remaining 7 bits become ones. This is the range 0 to 127. In certain textbooks, when they given a range, they will give like this: either 0 to 127 or 1 to 127 or 1 to 126. So whatsoever it is, there is a thing is there, so they don't. I will tell that one. Okay, so why they are mentioning like this? So next one is, this is 127. What is the after 127? 128. That is in the binary. It is the second one. So class B is the second one. So what I have done, so I kept these two same. Now remaining will be changes. Remaining become ones. So 128 to 191. This is the value. Okay. Next, it is a 191. What is the next value of 191? Means what is the next value of this one? 1100 like this. So again, it is a third one. Class C is a third one. So what I done? So first three are kept like that. So no change in it. Okay. And remaining become ones. Remaining zeros become ones. It's like calculating a range. Okay. This value is 192. Okay, and 223. So sorry. Yeah, 223. Correct. 223. Okay, you have to calculate and convert this number into decimal format. Okay, what is the next number? 111 0 0 0 0. So class D is the fourth one. So first four bits I kept like that. Remaining become ones. 224 to 239. Okay. Next, what is the next number? Is 4 ones, 4 zeros. Okay. So it is the last one. So we don't do any magics here. Okay. So straight away we're writing it. 40 to 55. Okay, guys. These are the classes. In this one, class E. Some people say it is R&D type. It means we don't use it. Use in some special cases or special places are reserved. Reserved. So we don't use it. We don't use it. Okay. This is called a multicast IP address. Multicasting. Multiple multicast. Multicasting purpose. Okay. We cannot assign to anything. Device. We can't assign to any device. And these are unicast addresses. There are unicast addresses which actually use can assign to device. Unicast, this unicast I said that these three are unicast addresses. So I am writing here class A, class B, class C, unicast IP addresses. So we can assign to a devices. Okay, guys, few things we cannot assign again. So we cannot assign to the devices or NICs, whatever it is. Okay, what are those? 0 series, guys. 0.0.0 we can't assign. Okay, because it is reserved address, generally used by some services like DHCP, client side services. Okay, default routing, default static routing purpose. Okay, some other places they use it, and entire 0 series we don't use it. Next one is 127.0.0.1, also reserved. It is called a local host or loopback. Local host or a loopback address. What is this local host or loopback address? Very good. I'm assigning some IP addresses, guys, here. No one is speaking anything. Whether you know or don't know. Okay, guys. I assign an IP address here. Okay. For example, I am trying to assign a 0 series or 0.0.0 and trying to go to the next. See, invalid IP for this subnet entered. Okay, invalid IP address or 0 dot something I am trying to assign. Okay, so it is invalid IP address. For example, I am trying to assign 127.0.0.1. Again, invalid IP address. Okay, so I'm assigning normal IP address 11, I think it is. It is accepting that IP address. Next, that is 11.11. This is 11.13. So I have how to communicate from here. From 11.11, so I'm pinging to 190.168.11.13. I'm pinging. Okay. So one system to another system when I'm communicating. I'm communicating right like this from 11 system to 13 system. I communicate. Okay. For example, I use a ping command 127.0.0.1 to who I'm pinging to the same machine. The PC0 is trying to test communication to PC0 only. That's it is called a loopback or a local host. Used for a self-test purpose, self-PC access purpose. I will show you one thing, guys. This is my one of the server, and it is enabled with HTTP on, HTTPS on, and there is some files are there. So I am trying to open. Okay, I will open. This is also having an IP address I configured 123, 11.123. From this PC, I'm accessing that PC. From PC 0, I'm accessing this server. I go to web browser. I'm trying to access that server, right? Means that server IP address is required. And also we require a protocol. It is, I got some information. Welcome to Cisco Packet Tracer, open doors to new opportunity, mind wide open, and the links. Okay, so how can I get it? Because this is a server and server IP address, I communicate. Okay. So now I'm going to, yeah, tell me.
Please explain again. Server.
This is my web server. Okay, this is my web server. So I'm accessing a web server from this PC, PC0. From PC0, I'm accessing a web server. Web server IP address is 192.168.11.123. Okay. So from my PC, I'm accessing the web server. So which protocol? HTTP protocol. I'm accessing web page, right? It has a web page. I'm asking, give me your web page to my server. I got a web page. What are the web page it is contains? I got it. Okay, so that is the point of IP address and the protocol and the service. Okay.
Okay, sir.
Next, this is a server, right? It is itself a server. See, it is a server 0. It has an IP address. I want to access this server's web page from the server only. From this server only. What I am doing is http://127.0.0.1. So I got information. From where I am accessing? From server only. And where is the web services are located? In the server only. So same system access. Okay. If I do, for example, the same URL I try on my desktop. So you see in this one, this is my one of the PC. So I am trying to connect it from here. Okay. See, it is not opening. Why it is not connecting? It connected from here, but not connecting from here. Because when you say 127.0.0.1 means you are trying to access from your PC only. This is not a web server. It does not contain any web services. And I'm trying to access from here to here only. From and to address is same. Okay. I think I understand. So
Yes,
127 means from address to address. Both are same. Same machine. Same machine access.
Sir, what happens?
What
Sir,
happened?
what happens if we didn't mention that HTTP protocol?
Maybe sometimes it will understand because earlier days of web browsers you should mention compulsory HTTP or HTTPS kind of stuff. Now almost we are running based on a Google only. Okay, so automatically the browser or the search engine will tell you what kind of link it is. It automatically put a HTTP or HTTPS, even if you don't type it. For example, here I am giving 192.168. It purely depends upon a browser, guys. 123. So I didn't mention HTTP, but automatically it is taking. Okay, it may be a HTTP or it may be a HTTPS. It will try. Earlier days, it's not like that. Earlier days, compulsory you have to tell HTTP or HTTPS. Okay, guys, that is the point of localhost or loopback address. So, what is the use of this one? Same device and use it for testing. On same device access and also use it for a testing purpose, test purpose also it will be useful. Guys, I installed a Oracle 21C database in my PC, in my laptop, and I have a client application SQL plus or a SQL developer client application is there, and this is a server application and this is client application. Both are in the same PC. So I want to connect with my client application to server application in the same PC. What I will use it? I can use loopback address or localhost address. Okay. For example, for another PC in the same network, both are in the same network, other PC is there. Here's the client, means SQL plus or a SQL developer client application is there, and server is here. You cannot use 127.0.0.1. If you use it, you try to connect from local only. But originally server is located here. So what I have to give here? This PC IP address. Okay, this PC IP address I have to give here. For example, this PC is 10.0.0.116. So here I have to give 10.0.0.116. Okay, so to communicate from outside, you have to use an IP address. From you are communicating within the system from same device, or we can say within the device or system, within the system, device or a system. Use 127. And enter this series also we are not using. This is not in the same part, but it is different part. So 169.254 something dot something. So this is called a APIPA, automatic private IP address. Okay, this is a automatic private IP address. This is also we cannot assign to any device. It's kind of error it is. Okay, when a device failed to get IP address from DHCP server or IP address conflicts occurs, system assigns an IP address from IPv4 range. Is 0.0.0.0, sorry. So 169.254 x 0.1 to 169.254.255.254. Okay, so this is the IP addresses, IPv4, IPv4 classes, and their ranges, guys. So I have taken a lot of time. When we have to small parts, we have to add it in IPv6. Then we'll take a break, small break, and I will come back. Okay, so we'll get back. I didn't give any break from morning, right? Okay, guys, remember one hexadecimal number. I given one hexadecimal number. The highest number is F1 hexadecimal number, represent in binary if 4 bits. Okay, it represents in binary 4 bits. Okay, how many bits we have? 128 and divided by 4, so it is around 32 hexadecimal numbers. Okay, so in IPv6 there is a 32 hexadecimal numbers are there. Okay. So this 32 hexadecimal numbers divided into 8 blocks. Divided into 8 blocks, separated by colon. Separated by colon. Okay, it means each block has 4 hexa numbers. Each block has a 4 hexadecimal numbers. And how it is already given. Okay, and we have a classes here. Okay, in IPv6 also we have a different things also here. That's the point. Okay, so already have taken a lot of part. So one thing we have to do, small exercise is there. Last exercise, guys. One exercise, then I will give you remaining information. Already people are not speaking. I don't know what to do. Guys, recognize an IP address. For example, I am writing an IP address in .16.176.192.23. This is an example IP address. Guys, to recognize which class of IP address it is based on the first octet, based on the first octet. What is the first octet? 16. What is the first octet? It is 16. So 16, you check this table and 16 is in between this. So it is a class A IP address. 167.8.134.51. So you should use dot, not comma, guys, or don't say it is point. Okay. Because I will change it. It's 251. Which class of it is? Which class it is?
Class C.
Very good. 167. Look at the first octet.
Class B, sir. Class
167
B. Class B.
in
Sorry,
between.
class B.
Okay, class B. Very good. Even it is wrong also, no problem, guys. So try. If you try, it will understand very easily. For first time, people will come. 123.78.77.168. Very good. Check the first octet always. Whatever the remaining numbers, guys, don't mind about it. And then nothing is more than 255. Important is no octet is more than 255. And for checking a class, you must check with the first octet only. 123. In between this, it is a class. Correct.
Class, sir.
Class B, sir.
Very good. It is
Class B.
B. So how it is class B? Check the first octet.
168 to 128 to 191.
128 to 191. So below 191, it's a class B.
Class C, sir.
Class C, sir.
Class C. Very good. How it is a class C? Check the first octet. Okay. No octet is more than 255. So check the first octet. Why we should check no octet is more than 255? To make sure it's a valid IP address. And next one is first octet 201 is in the class C. Okay. That's a class C range.
Class D, sir.
Class D. It's 126
Class D.
and it is class D. Okay. So this is how to recognize IP address based on what class it is. Okay. Just take a break, take a 10 minutes of break, relax. Just before only I want to give a break, just mute it. Okay, take a 10 minutes of break. Then we'll continue the IP address, subnet mask kind of stuff. And network portion, host portion, little lengthy class. Otherwise it won't be completed.